In this session, we're going to look at hashing, alright, fundamental of hashing of what it is, and where is it commonly used. We're just going to go through some example of its use. First of all, what is hashing? Well, hashing is actually an algorithm, alright, such as MD5, SHA-256. Right, it's just an algorithm. What it does is it takes some input. It could be a file, it could be a bunch of strings, alright, and convert it into a hash value. Alright, and the hash value is actually unique to the input itself, which means you are not going to have two different input producing the same hash value. Alright, and this is particularly important sometimes in digital forensic, because we do not want our digital evidence to be tampered with. So the digital evidence itself is the input, going through a hash algorithm, producing a hash value, and you keep records of this hash value. So if the input, or in this case the digital evidence, is ever tampered with, it will produce a different hash value, and you will know that it has been tampered with, and that will invalidate the entire digital evidence itself. Other areas of common use of hashing is comparing of files or data, especially if the files and data could contain very small differences that is probably very difficult to detect. So what it can be done is both these files can go through the same hashing algorithm, each producing its own hash value. Then have these two hash value compared. If the hash value actually comes out to be the same, then these two files is actually exactly the same. Alright, because it is impossible for two different files as input producing the same hash value. Other areas that commonly use hash values or hashing is actually in dealing with your password. Okay, imagine you are signing up for a new service. Okay, so you are setting your password, but instead of having your password stored directly into the database, the password could go through a hash algorithm, and the hash value of your password is the one that is stored in the database. So the next time when you log in or sign in to the same system, your password that you have just key in, will go through the same process, go through the hashing algorithm, produce a hash value, and this hash value will be compared with the hash value that was previously stored. If it's the same, then you get to log in and then use the application or use the system. Now, why go through this process instead of storing your actual password onto the database? First of all, it's because of the database administrator. If a database administrator were to look into the database, do we want the database administrator to actually see the plain password that you have typed in? In this process, the database administrator will only see the hash value. Alright. A second is the hacker itself. Since we are sending this value of your password, which is somewhat sensitive, alright, confidential in nature, over to the database or for checking, you do not know who is intercepting your data, right, over the Wi-Fi, over the wide area network, and so forth, or even over the internet. So by using the hash value instead of your password, even if a hacker were to actually intercept successfully, right, the packet that you send over, he or she will only see the hash value. and not the plain password. But do take note that although hashing appears to be a good process, alright, but hashing, especially plain unsalted hash, has its uses, because by brute forcing we can still get your password.